All right, here we are in our second lesson of this unit, and today we're going to talk about graphing functions. So represent linear functions using ordered pairs and graphs. So we've worked with graphs before this year. Now what we're going to do is just kind of learn a skill of tracking things as far as it comes to functions and ordered pairs. Here's your warm-up today. So what I want you to do is write an equation and tell what the variables represent. You don't need to answer it. You just need to write an equation and tell me what your variables represent. So go ahead and do these two and then come back. Remember, there might be some variation in what I have compared to what you have. So here are the answers that I came up with. So for number one, I just made L length and H height. And L equaled 3 times the height, so 3H, 3 times H, plus 4. So for number two, I did C for cards and B for buttons. So the number of trading cards is 3 less than the number of buttons. So C equals the amount of buttons minus 3. So you should have answers similar. Your variables might have been different, but your organization of your equation should have been close to the same. All right, so let's talk about finding these solutions. So the first example we're going to talk about in this unit is to be able to find solutions of equations when you have two variables, x and y. So we're given for this problem in the directions y equals 4x plus 2. We have y and we have x. Those are our two variables. Now, the following part of the question does tell us that x equals 1, 2, 3, and 4. So all we have to do for all the x's is plug in 1, 2, 3, and 4, and we'll see what we get. So first thing that you should do is make a function table by using the given values of x in their own column, the equation in the second column, and the third column is y, and that's where you're going to put down your answers. So in the first column, we just have to plug then the value of x, the input, into the equation in the second one. So for the first one, it'd be 4 times 1 plus 2. 4 times 1 plus 2, well, 4 times 1 is 1, plus 2 is 6. And 2 would be 4 times 2 is 8, plus 2 is 10, and so on. So on the third column, you would just fill in those values. So you get y equaling 6, y equaling 10, y equaling 14, and y equaling 18. Now, the last step to show your answers is you have to write these solutions as ordered pair. So you have to check if an ordered pair is a solution of an equation simply by just putting in the x for x and putting in the y that you got for y and seeing if they equal. So that's how you can check your work. So first though, write the ordered pairs and you'll see that you get 1, 6, x and then y, 2, 10, 3, 14, 4, 18. Now the directions could say now graph them on a graph, and if that was the case, you would just have to get an ordered pair or a graph and mark each of those ordered pairs. Because both the x and the y are positive, that would be in quadrant 1 of a grid if you're using just a standard grid. So that's how you find the answers. Plug in what it gives us for x into the equation, and that'll tell you what you get for y. Your answers are then written in the ordered pair under parentheses, like you learned earlier this year how to do. Make sure you have this example down before moving on. All right, so here are two problems, and you can try them both on your own. If you want me to go through number one with you, I will. Just pause the video now if you want to do both on your own. Okay, so remember the directions we just went over. The first step should be to make a table, and second is you're going to list your ordered pairs. So we'll make our table for x, the expression, or the equation, and then y. So for the first x, we have 1, then we're given 2, then we're given 3, and I should just make another box here for 4. So write the equation, y equals 6 times, and here we can put in 1, plus 2. This next one will be y equals 6 times 2, just putting those two in, plus 2. 3 is y equals 6 times 3 plus 2. Again, just dropping the x in for x and seeing what we get for y. And y equals 6 times 4 plus 2. Now we just got to solve the right side of the equation to see what y equals. 6 times 1 is 6, plus 2 is 8. 6 times 2 is 12, plus 2 is 10, or sorry, 14. 6 times 3 is 18, plus 2 is 20. And 6 times 4 is 24, plus 2 is 26. So our answer should be 1, 8, 2, 14, 3, 20, and 4, 26. And again, how do we check to see if this is correct? Let's just pick one. We'll pick this one. And then we put the numbers in for y and x. So we know y is 26 equals 6 times 4 plus 2. And 6 times 4 is 24, plus 2 is 26. So 26 does equal 26, so that is correct. All right, now go ahead and try number 2 on your own. And if you already did number 1 and 2 and you're waiting for me to go over them, a couple seconds and we'll be completed. I'm just going to be putting the ordered pairs down for this. All right, so these are the answers you should have gotten for number 2. And as you can see, every single y is a negative number. Why? Why is that? Well, I hope you notice that here y equals negative 2x. Negative 2x. So that means for each one of these, we did negative 2 times 1. Well, a negative times a positive makes a negative. Negative 2 times 2. Again, positive and negative makes a negative, and so on and so on. So these are the correct answers you should have had. If you got that right, and if you did one on your own and you got all those right, come on over and give me a high five. You're getting this. You understand it. All right, sometimes you might see an expression like this if you're trying to graph functions, where it's just saying, hey, we got 3, 21, and the equation we were given was y equals 7x. Is 3 and 21 equal, or do they fit? Is it a solution or not? Well, all you have to do for these then is you just have to first write the equation as it says, and then plug and chug the numbers in where they need to be. So the x in this is always the first number, and then the y. So the x3 goes in here for x, and 21 is y, so that goes there. So y equals 21, and x is 7 times x. 7 times 3 is 21. So because 21 equals 21 on both sides, you know that y equals 7x is a solution for 3 and 21. It's that simple. Just being able to check to see if it makes sense. Go ahead and write this down so you have an excellent example before moving on. All right, your chance. You can do both on your own. Come back when you're ready. If you'd like to see me do one more with you, stay on for number 3. Otherwise, pause the video now to do these on your own. So for number 3, we're given y equals 4x. The first step is to write it down. The second step is to replace the y with 12 and x with 2. So 12 equals 4 times 2. So 12 equals 4 times 2, that's 8. So does that equal? No. So you draw the not equal sign. So you can say y equals 4x is not a solution for 2, 12. Okay? Go ahead and do number 4 on your own. And number 4 you found out is a solution because when you do 2x, that means 2 times 5, which gives you 10. And then as you can see, I had to do 10 minus 1, and that gives you 9. So it is a solution. And for those that did these both on their own, for number 3, it is not a solution because they both don't equal 12. So if you got both of those right, come on over and give me a fist pound. So we have a little bit of vocabulary here I want to go over before we do example 3. We're about halfway through our lesson today. So we can also graph the solutions of an equation on a coordinate plane. So when we graph the ordered pairs of these functions, they should form a straight line. If they do, then we know that that is a linear equation. It means they're equal all the way across the line. You're consistent. So what I want you to do is make sure you get at least that last sentence down. The equations that express these functions are called linear equations. But I would encourage you to write the whole paragraph if you could. All right, let's look at example 3 now about actually graphing. So in this example, you have to use the graph of a linear function to find the value of y for a given x. Well, if you know how to find x, all you got to do is put it on a line or find x on the graph and see if it where it matches up on the line. So because we were given x equals 4, what you want to do is start at the origin. And the origin, you should remember, is 0, 0. So if we start at 0, 0 and it says x equals 4, the x-axis is the one that goes left to right. So that means that we have to move 4 spots. 1, 2, 3, 4. Now the next step says to move up until you reach the graph, or at least the line on the graph. Do 1, 2. So where the red dot is 2. So when x equals 4, y equals 2, that's one way you can write the answer, or you can say the ordered pair is 4, 2. It's that simple. Have this example down before moving on. All right, so for here we have the line. You need to find the y value for x equals 1, x equals 0, and x equals -1. You can just write down the ordered pairs if you want, or write y equals. Either will be fine. Come back when you're done. Here are the answers you should have gotten. So if you went over to the right on 1 and you went up the graph, you'd see that it crosses at 2. So y equals 2, or the ordered pair is 1, 2. For number 6, we start at the origin of 0. So we don't have, all we have to do is go straight up to 1. So our ordered pair is 0, 1. And for 7, x is -1, so the first move is to the left, -1. And you can see the line intersects right there at -1, 0. So that's how we get that ordered pair. If you got all 3 of these right, I want you to give a high five to a random person in class. Now, putting it all together, being able to find functions on a table, and then being able to graph things, we can now take all 3 parts of our lesson and put it together here in example 4. So for us, what we have to do is graph the function described by the equation y equals -x minus 2. So for how to solve this, we take everything we've done. First, make a function table. Okay, x in the first column, the equation in the second column, y, your other variable, on the third column. And then all you have to do is make up 3 values of x. So I decided to use -1, 0, and 1. You could do 1, 2, and 3. You could do 0, 1, 2. You could do 0, -1, -2. It doesn't matter, but you need to have at least 3. So now all I did is I plugged x in for each one of these. And then what do I get? Well, -1, -1 makes that a positive, right? So 1 minus 2 is -1. 0 minus 2 is -2. And -1 minus 2 is -3. So that's the first step. Second step, you write the pairs down in ordered solutions. -1, -1, 0, -2, and 1, -3 are my examples. So if you ever have to do these on your own in your homework or in the practice you're going to do in a little bit, I would encourage you to do what I did with the x's. -1, 0, and 1. Write these down before moving on because the last step is to graph it. And here is our graph. So all I did is I took the 3 ordered pairs we have here, -1, -1, 0, -2, and 1, -3, and I graphed them. -1, -1, made a dot. 0, -2, made a dot. 1, -3, made a dot, and then you just draw a nice straight line using the edge of a ruler or something, And that's how you actually graph the ordered pairs to show that y minus negative x minus 2 equals this line. That's how you do it. All right, so here is yours. I'm going to let you pick 8, 9, and 10 as the 3 you're going to do. But again, if you want, I will go through number 8 with you, and then 9 and 10 are on your own. So if you want to start all 3 on your own, go ahead and start now. Otherwise, wait, and we'll go through number 8. Okay, remember, first thing you want to do is make a table. Hopefully that's big enough. Let's see, y and x. And I said 1, 0. Oops, do this. I'm going to do the same as I did last one, negative 1. So we're going to replace x with 1, 1 plus 3. We're going to replace x with 0, 0 plus 3. And we're going to replace negative 1 for x, negative 1 plus 3. 1 plus 3 is 4, 0 plus 3 is 3, and negative 1 plus 3 is 2. So our ordered pair is 1, 4, 0, 3, negative 1, 2. So I'll make my little graph. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. And now I just got to graph them. So we go over 1, up 4. That's our first, actually I'll do a different color. That's our first ordered pair. 0 up 3 is our second ordered pair. And negative 1 up 2 is our third. And then all I got to do is draw a line. Boop, little arrows, boop, and I'm done. Okay? Go ahead and do 9 and 10 on your own, and then come back and I'll show you the answers. And here are the 3 answers you should have received for 8, 9, and 10. So 8 we did together, most of us. 9, you can see that I came up with 1, 2, 0, negative 1, and negative 1, negative 4. Because for x I used 1, 0, and negative 1, just like it did in 8. Made a nice straight line. You can see I made a little mistake here, but I just ignored it. And for number 10, I made it 1, 1, 0, 3, and negative 1, 6 by just doing x as 1, 0, and negative 1 and plugging it in. And you can see this one makes a straight line opposite of the other two, different direction. So that's how you can that's how we can graph them, and we can see that they're linear equations. Everything works out perfectly the way we want it to. So if you got those as answers and your drawings look pretty close to mine, give yourself a pat on the back. You're doing great at this. You're understanding it really well. Okay, go ahead and work on your box of thought here. Explain why the points in example 4 that we did, that'd be the one I did before you did your own practice, are not the only points in the graph. How could there be more points along that graph? Think about what we chose and how many different numbers you possibly could choose. Number 2, tell whether the equation y equals 10x minus 5 describes a linear equation. How could you figure that out? You don't actually have to solve it, just tell me. And here's your quiz, question 1, 2, and 3. So go ahead and work through these. Question 1, you're basically making a table. Question 2, you're going to determine whether 4, negative 2 is a solution to this problem or not. Plug and chug. And for number 3, you're going to do just like we did in example 4. Good luck, and can't wait to see your answers all well thought out and drawn out correctly in your notebook.